Hey everyone, we are from Delo. First of all, let me introduce myself and my teammate, I'm Ng Jin Neng, and this is Patrick Tang Sang Yi, Yap Hao Hui, Chan Kai Jian, and also Marcus Lau Hui Wei. Today, our group are going to discuss about the decommissioning of nuclear facilities. The asset that has been selected in our study is the nuclear facilities. The main reason why the nuclear facility has been selected in this study is affected by the globalism and dramatically improve in technology, and there's the need to decommission these assets. What is the term decommissioning of assets? According to IAEA 2007, the term of decommissioning refers to the administrative and technical action required to authorize the removal of any or all the regulatory control from a facility. For the better understanding, decommissioning is the action that are taken at the end of the useful life of a facility in withdrawing it from the service.
So what are the processes involved in nuclear facilities decommissioning or disposal? For abandonment planning, there are 8 main components which can be listed as: first, preliminary and ongoing planning; second, navigation of reasons; third, cost estimating and financing; fourth, characterization of radioactive materials and facilities; fifth, management of transition from operation to final decommissioning; sixth, planning of project organization, management, and human resources; seven, public engagement and stakeholder consultation; and finally, eighth, review on safety regulations and licensing. For executions, there are 6 main components which can be listed as: first, dismantling and demolition process and technologies; second, decontamination process and technologies; third, remote operation and robotics technologies; fourth, radioactive waste management; fifth, environmental remediation and restoration; and finally, sixth, site clearance and license termination. For strategies used in nuclear facility decommissioning, there are 3 common strategies, which are immediate dismantling, deferred dismantling, and finally endowment dismantling.
Hi, I'm Yap Hao Hui, and I will be explaining about rules and regulations imposed in decommissioning the nuclear facilities. Rules and regulations in personnel health and safety issues will be discussed here. In justification of practices, no practice or source within a practice should be authorized unless the practice produces sufficient benefit to the exposed individuals or to the society to offset the radiation harm that it might cause. According to IAEA 2018, the limits of effective dose are 100 mm SV in 5 years and 50 mm SV in any single year. On the other hand, in the sense of exposures from any specific source within a practice, sufficient containment and shielding of radioactive material, both natural and accidental, is accomplished by complying with the IAEA transport regulations. In safety culture, active involvement of staff in safety matters is of paramount importance to enhance their interest and commitment. This can be achieved by training, refresher courses, and in-depth discussion of events in the teams involved. Last but not least, it's essential that the demarcation between the different areas is strictly maintained to avoid spread of radioactive contamination in order to ensure their protection and safety. Most countries have implemented regulatory requirements for protection to the environment. In the countries of the European Union, European Directive requires that before the construction and operation of a nuclear facility, an environmental assessment be conducted in which the hazards of the facility for the environment are evaluated. Besides, clearance levels in European Commission specify radiological concentration to be below which materials can be considered non-radioactive and released from regulatory control. Lastly, the segregation of materials for recycling and reusing can be an effective way to minimize the amount of radioactive waste that needs to be managed.
Hi, I'm Chan Kai-Sian. We'll be presenting about cost of decommissioning nuclear power plant. Since the decommissioning of nuclear power plant involves huge amount, cost estimation is thus very crucial. Various estimation methods have been developed, such as U.S. Nuclear Regulatory Commission (NRC) method and site-specific studies method. Now let's look at one example for the NRC method. Let's say a 2536 megawatt boil water reactor was to be decommissioned in year 1986. We will use value of P equals to 2536 and substitute it into this equation to find the minimum founding amount in year 1986 if it is true immediate dismantling method, and we get 126.824 million. If the decommissioning process prolonged until year 2002, we have to find the escalation factor which consider the labor cost, energy cost, and waste burial cost. By multiplying the escalation factor and the MFA, we will find the estimation cost in 2002, which is 424.36 million. The decommissioning cost estimation through site-specific method is more accurate than NRC method, as it considers three types of costs, which are activity-dependent costs such as decontamination, removal, transportation, and burial, and also period-dependent costs such as utility management, decommissioning operations contractor. Last but not least, collateral costs such as engineering, purchase equipment, licensing, insurance, and taxes. Table 1 shows the comparison of estimated and actual decommissioning costs of main Yankee nuclear power plant in US. As we can see, it estimated a value of 530 million US dollar compared to the $577 million. The accuracy is within 9%. In France, EDF estimated a total decommissioning cost of more than 79 billion euro for the immediate dismantling of 58 reactors in 2016. Similarly, in Germany, immediate dismantling is also applied, and the estimated decommissioning cost is 6.5 billion euro for both Greifswald and Rheinsberg plants in 2016.
I'm Marcus, and I will discuss about managing the risk during asset disposal. So when we're disposing a nuclear facility, it actually involves a large volumes of different materials and different kinds of goods. So the risk is actually associated with operational safety. This is because many kind of accidents may happen during lifting, cutting, and so on. Besides the operational safety, the radiological safety must be discussed as well, because the activations of fission products which form in various systems and structures during reactor operations could become airborne when the workers cut the large structures into smaller pieces. This kind of product is very harmful to the workers or the public. So in managing this kind of risk, a safety assessment must be done before the decommissioning process. The safety assessments will provide the systematic evaluations of the safety consequences of both the decommissioning process and possible accident scenarios. So, the safety assessment must consider all the relevant hazards involved, such as radiation exposure, fire, maybe things dropping from high place, and so on. So this kind of hazard must be considered in the safety assessment. The safety assessment must be consider the exposure of radiation as well, because they must minimize the exposure of radiation to the workers and the publics. The safety assessment must consider the materials management as well, because the material, like, consider the radiation is very harmful to the workers and the public, and also the uncertainties like fire, high temperature, or so on. Okay, that's all from me. Thank you.